Yep. Yeah, one from that too. Wait, so you didn't do anything yesterday? You didn't practice yesterday?
Oh yeah, man. Hard is it? That's what you guys talk
That was fun though.
Take out the packet of death, please.
I'm trying.
the Rodriguez nuts.
Yeah. So I think the first one that we did not go over yet is number 90 on page 5. Okay, so we're going to, remember these are questions that will appear on your test. We're going to get through, I don't know if we'll do the whole bag, you'll try to do at least most of it. So, let's talk through what each of these things mean. So, twice differentiable just means you can take the derivative twice. So, not like quarters or cusps or asymptotes or anything weird between 2 and 4. What does that mean? Somebody raise your hand and tell me. F prime of 3 equals 2. Or I call people. Naomi. On which graph? On the original graph, when x equals 3, your slope is 2. If your derivative is 2, that means the slope. So, slope at x equals 3 is 2. F double prime of x is less than 0. What's that mean? Second derivative is negative means the original graph is concave down, right? So we got two things going on. The slope at 3 has to be 2, and the original is concave down. Well, if the original is concave down, what is happening to the slopes? Decreasing. Concave down means your slope as you go is getting less and less and less and less and less. So this here means your slope is decreasing. Which is the same thing as concave down. It means both of them. So what I looked at first was, I noticed in D, the slopes are not equal. Okay. So I looked at the slopes between the points. So the distance between that point and that point is 2.5, so that's your slope. Your slope there between those two is 1.5. Here it's 2.5 and 2, 2 and 1.5. Those three are all decreasing slopes, right? So that meets the concave down requirement. Here, the slope is 2, the slope is 2. Is that a slope that's decreasing? No, it's just staying 2. Here, the slope is 1.5 and 2.5. So that slope is actually increasing because they're getting bigger. So we know it's A, B, or C based on that. Then the next thing is they tell us the slope at 3 has to be 2. Well, if I look at, let's say I look at C. Before I get to 3, my slope is 2. After I get past 3, so like 3 to 4, my slope is 1.5. So at 3, it's somewhere in between these two numbers. It's between 2 and 1.5. Well, is 2 between 2 and 1.5? No. So the slope at 3 here is a number in that gap. The slope at 3 here is a number in this gap. You notice how in that gap, 2 fits like perfectly. That's what they're looking for. So the slope from 2 to 3 is 2.5. So like just prior to 3 is 2.5. Just after 3 is 1.5. So somewhere in there was that switch when it hit 2. How's that one? It's kind of a tougher one. Questions? All right, 21. So this is the position graph. So that's what the x of t means. And they want to know when the velocity is increasing. Well, here's how I would process that. I'd say, okay, velocity increasing. What's velocity mean? What level are we at? The derivative, or it's the same as slope, right? So couldn't I say that means the derivative is increasing? Or the slope is increasing. And so all those three things mean the same thing, and they all mean what? If your slope is increasing and getting bigger as you go, what shape is that forming? Concave up. All of those things mean concave up. So the velocity is increasing, the slope is increasing, the derivative is increasing, your surfboard as you go is increasing. So you want to know where the original graph is concave up, and that's this little section right here, because it looks like a U. So from 0 to 2, and then we get this switch, and all of a sudden it starts to look more like an N. So this is tough, because they give you, they tell you velocity, which is the derivative level. You have to get to the second derivative level to answer the question about the original graph. So you got all three levels going on in there. Once you kind of wrap your brain around this, I think it's not bad. It can be hard to get there for sure. I think I can clarify on that one. All right. 84, where is f decreasing? Well, we have a graph of the derivative. So anytime we're below the axis, that means our slope is negative on the original graph. That means the original graph is decreasing. So from 0 to 2 and 4 to 6. So E, because that's where we're below the axis. 87, how many relative max are there? So this is the derivative graph. So again, what does above the axis mean on a derivative graph? The original is increasing. Below the axis means the original is decreasing. So the original graph is decreasing here, increasing all of this time, and then decreasing here, and increasing here. And I want a relative max. Well, if I want a relative max, that means my original went from inc to dec. So that happens once, right there at whatever x value that is. But this would mean the original graph was increasing over here, decreasing here, so you get the top of the hill. So there's just one. How many relative mins does that graph have? 2. That would be this guy and this guy. How many points of inflection does that graph have? Not that, sorry. How many points of inflection does f of x have? This is another level. This is tougher. That's not 3. How many points of inflection does f have? How many? Nope. Nope. Nope.
Pick one, Chris.
27.
42. That's the easier one.
Okay, what's the point of inflection? Change in concavity, right? What's concave up mean? Increasing what? Could I say increasing derivative? Alright, what's concave down mean? Decreasing f prime. So if I switched from an increasing f prime to a decreasing f prime, Wouldn't that be a switch from concave up to concave down? And wouldn't that be a point of inflection? Or the other way around. So I kind of screwed up my graph because there's a head all over it, but your derivative is increasing here and decreasing there. So this is the point of inflection, this is the point of inflection, this is the point of inflection. It's the peaks and valleys. It's the max and mids. So there'd be 4 points of inflection. Question on that? Or like my made up extra version? Right. So they give me this graph, and this graph is the derivative. So every y value on here represents what? The slope of the original graph. So for example, what is the slope of the original graph when x equals 1? 3. So x equals 1, if you read off the y value, that's your slope. What is the value of the second derivative when x equals 1? How do I go down a level if I'm looking at a graph? It'd be 0, because how do you go down a level if you're looking at a graph? You take the slope. So at x equals 1, if I take the slope here, that tells me my second derivative is 0. Doesn't that make sense? Because what is that on the original graph? What is this point? Like, think about the problem we just did. It's a point of inflection, isn't it? So shouldn't the second derivative be 0? It's like turning from positive to negative or from negative to positive. Okay, so line tangent. So tangent lines are going to be this. Put the 3 and the 5 in there. And then what goes here is the tangent line to the original graph. What goes here is the slope of the original graph. What is the slope of the original graph when x equals 3? It's 2. And then you're getting that by reading this graph. If you take the slope of this graph, you've gone down a level and you're at the second derivative. That's not what we want. So they just got to rearrange this. That's the same as if you put the 5 on the other side. So that was C. Alright, how many points of inflection does F have? This is the same question I just asked you on the previous one. Points of inflection, if you're looking at the derivative, points of inflection happen where? The peaks and the valleys, right? So points of inflection will be 1 there, 2, 3, 4, 5, 6, because that's where the derivative switches from increasing to decreasing or decreasing to increasing. So there are 6. And then number 9 is a new question. We haven't quite talked about that yet. I'm not gonna do like as in depth here, but I want to start talking about it. When does the absolute minimum of f occur? So this is the lowest point on the original graph between 0 and 8. So you gotta picture what's going on here. In this entire section here, what's true about f prime of x? Positive. It's above the axis, right? So what is the original graph doing that entire time? It's increasing. And it's going to increase by the amounts of whatever shaded area is down here. So I'm not going to have to find it, but I want to keep in mind that I had some starting point. Then I increased by this amount. So, my original graph might start here, and it increases until I get to 6. Then, what's true about the original graph? What's the original graph doing down here? It's decreasing. And how much does it decrease? It decreases by this shaded amount. So did it decrease more or less than it increased? So it only decreased maybe down to there. Fair enough? Increased all of this area, so we got way up there, and then we came down a little bit. Well, they're asking where's the absolute min? What x value had the lowest y value with it? X equals 0. We started here, went way up, and we didn't ever make it back down to where we started. So isn't that where the lowest point was? So it's going to be x equals 0. Where's the highest point? Where's the absolute max? At x equals 6. Because we increased all the way up until there. And then we it down a little bit because that's where below. How's that? Okay. So keep in mind, I mean, I know it's not like super engaging or fun to sit there and like watch me go through problems for an hour. I understand that, but these are test questions, so you know, try and stay with me and ask questions if you have. All right, number 12. How many max and how many relative max and relative mins? This is the derivative. So that means the original was decreasing over here. The original's increasing there. The original's decreasing there. The original's increasing there. So right here is a relative which? Min, because the original changed from dec to inc. This would be a relative max. This would be a relative min. So I have two relative mins and one relative max. So A. All right, 17. I just wrote out kind of a list. So f of 1, this graph is f of x. So f of 1 is 0. That's just like what's the y value. F prime of 1, I don't know the number, but I wrote that it's positive. How do I know it's positive? Because the slope's positive, right? Yeah.
Why is that graph the original, not the second derivative?
Because it says it's the graph of f. Twice differentiable means I can take the derivative twice. It doesn't mean it's the second derivative. Like, it's possible for me to take two derivatives. So why did I write f prime was positive? Because we got a positive slope there. Why did I write f double prime was negative? Because we're concave down. So I just put an order. So negative is less than 0 is less than positive is 2. Is that right? Alright, so going back and forth on graphs, they tell me this is f of x, and which one of these could be f prime of x. So to me, it's easiest to just go up to the top and graph it and sketch a graph, and then kind of match. But there's other ways you can do it. But I would look at this and say, okay, I know the slope of this graph up here in 3 spots. I know exactly what it is. I know there it's 0, I know there it's 0, and I know there it's 0, because I can see that it's flat in those spots. And then I'm going to look in each window and kind of connect some dots. So between A and 0, is my original graph increasing or decreasing? Increasing, which means my derivative needs to be positive or above the axis. So it's got to look like this. And it's got to come back to 0 at that spot, right? And then in the second section here, my original graph is decreasing, so negative slope, so my derivative better be below the axis. And then I'm just kind of looking to see if that matches up with A. How's that? Questions? No questions? Okay. 79. So which ones have a relative max? So those are all derivative graphs. So your derivative graph is going to show a max. A max happens when we switch from increasing to decreasing, right? So our derivative needs to switch from positive to negative, which would be like above the axis to below the axis. So that happens there. It never happens in this graph, and it never happens in this graph. So something there has to be A. Questions there? How many finished up to page, like I told you to finish the multiple choice when I was in here. So up to page 15. How many finished those? So this puts me in a spot of I'm going to continue going through them, even though 2 people did them and no one's even going to know what's going on. Or we just wasted like a day of class. How many people have these done? Yeah, like the rest of multiple choice. What did the sub tell you yesterday? Finish multiple choice. They did say that. And just you guys decided like, no, we're not gonna do that. Like, what am I supposed to do right now? These are my choices. I'm gonna keep going through and pretend you all did it, but you're not. Like, if I go through this question right now, you haven't read it, you don't know what's going on, you haven't thought about it, you haven't engaged, or okay, use this time to do that, which means we just wasted a day of class. We missed like 10 snow days. I mean, I'm sorry I missed yesterday, but I can't just give back a day of class either. Do you see what position that I put in right now?
Just because I didn't get through all the way through 15 doesn't mean that I didn't do some of these previous pages. I just didn't quite get all the way through page 15.
$13 questions. That's what I asked you to do. So how many of you finished up to page 10? Okay. How many started up to page 15 but didn't finish up to 15? Okay. Why did you finish? Is it like because you're stuck, or is it because you just didn't? You're stuck. That's okay. Doesn't tell you that. That's totally fair. That's fine. All right, I'm just gonna keep going through it because if you're stuck, you're stuck. If you didn't do it, you're bored. I guess that's your fault. We can't give up a day of class. And if you're stuck, that's a totally legitimate reason to stop. But I'm not quite sure that's it for everybody. All right. So here we're going back to like an algebra way. They give you a function, they ask where it's increasing and decreasing. So what levels of the problem do increasing and decreasing come from? Original, first derivative, second derivative. First derivative. So 3x squared plus 12 is my first derivative. If I try to solve that, then I would set that equal to 0. I get my critical points, because I'm trying to find like values to put on my number line. So you can factor out a 3, but that's not going to help. You end up with like this x squared plus 4 equals 0, or x squared plus 12 equals 0, which would be x squared equals a negative number. And we can't have that. So there's 0 critical points. So when I go to make my number line, there's no critical points on there to split it. So what's my interval? Negative infinity to infinity. So it's all one big interval. If you remember, we pick a point from the interval, which you can pick any point that you want, let's say 0, and plug back into where? I want to plug into the derivative because what's the derivative tell me? It tells me slope, which is increasing or decreasing, right? So if I plug 0 into the derivative, what do I get? Positive number. Right? It doesn't matter what I plug in. I'm going to square it, which makes it positive. I'm going to add 12, so I'm still going to be positive. So the derivative is always positive. That means that we are always increasing. So actually the third is one of these guys. So like you're just going up the whole time. Questions there? Number 8, dy dx is less than 0. What does that mean? I'm sorry, greater than 0. I don't know if I greater than less than. dy dx is greater than 0. What does that mean? What's positive? Derivative is positive. This means derivative, right? Derivative greater than 0, derivative positive. What's derivative positive mean? The original has to be doing. Increasing. So, it can't be this C to D interval because I'm not increasing there. And then if you notice, A to B is concave up and B to C is concave down. So like the next piece they're going to give me is going to tell me which one of those to do. So this means second derivative, and our second derivative needs to be less than 0. Our second derivative needs to be negative. So if our second derivative is negative, what do we know about the original? Concave down. So we need to be increasing and concave down. And that's this shape here, which matches up with between B and C. So let's look at these sections. Between A and B, is the derivative positive or negative? this section here, derivative positive or negative. Positive, how do we know? It's going up. Second derivative positive or negative. Positive, how do we know? So it's concave up. Here, first derivative, positive, second derivative, negative. Here, first derivative, negative, and now we're going down, second derivative, negative, because we're still in the concave down portion. Okay. Does that help? So those that are saying you're confused, is this helping? Is this helping you, like, overall? Okay. Somewhat. Are there, like, specific questions I can answer, or are you just still...
I think it was just the wording of everything is very originally, obviously.
Yeah, they like to word things like in the hardest.
This going over it's
Okay. 16. So where's their relative maximum? I don't have a graph, I have an equation. So what level does relative max information come from? First derivative. So first derivative is 3x squared minus 6x. What do I do with that? Set it equal to 0 to get my critical points. Second factor, I can take a 3x out. That'll give me x minus 2 equals 0. This will give me x equals 0 and x equals 2. So those are just like possibilities. Those go on my number line. You don't even need the number line really, but you know that splits it for me from negative infinity to 0, from 0 to 2, and from 2 to infinity. And then I take a point from each of those little windows and plug back into where? Into the derivative, you plug back into the level you came from. So if I plug in like negative 10, I'm going to plug in here. This part would be negative. 3 times negative number is negative. This part would be negative, so negative times negative means positive. So we're increasing here up until 0 because the derivative is positive. And so if the next part's decreasing, that makes a relative max. So that's what we're looking for. So if I plug in like 1, 3 times 1 is 3. 1 minus 2 is negative 1. So 3 times negative 1 is a negative. And we get this increasing, decreasing, which means up to down. And that is a relative max. So there is a relative max at 0, or B. Questions there? All right, 33, we're going backwards here, kind of. So they're giving me a derivative, and they're saying which one of these might be your original. Couple things, I don't know, a couple different strategies, I guess. But if my derivative, how many wiggles are in this graph here, the derivative graph that they gave me? 1. So my original should have how many? 2. So I cross off these, right? Because the derivative of this would just be like a horizontal line. This is the horizontal line below the axis. But I need to have 2 wiggles, so it's going to be one of these. So then I'm going to look at the derivative is 0 there and there. So what should the slope of my original graph be at those 2 spots? It should also be 0. Well, in A, when I'm at negative 1, is that slope 0? That doesn't fit. In B at negative 1, is the slope 0? Yep. At 1 is the slope 0? Yep. And in C, at negative 1 at 1, the slope is 0. So we're down to 2. And then I'm going to look at increasing, decreasing. So this tells me the original graph was increasing here, decreasing there, and increasing there. So I've got to go up, down, up. So let's be. Fair enough? Yeah, it's better.
After going over that, I have a question on 23 on page 10.
We're going backwards? Okay.
Is this that the one we just went over, it had 1 less bump when you did the derivative, but with this one on 23, it had. Oh, does that one have?
So, no, that's a good point. If I go back to the one we just did, I see like a clear 1 wiggle here. I see a clear 2 wiggles here, and I see a clear 0 wiggles here. That tells me that we're working with a polynomial, like an x squared, x cubed, x. We're like kind of every time you take a derivative, you knock off a power and you knock off a wiggle. This one, though, if you notice, like it doesn't. This is sine or cosine. So you know, if you continued this pattern, wouldn't it just keep doing this and this and this? So like technically, these both have infinite wiggles, and the wiggle rule, which is kind of made up and doesn't really apply always, doesn't work for sine and cosine because you have infinite. So like 1 less than infinite is still basically infinite. So it can't always fit. That's a good question. All right, thank you. Let's start giving bonus points for questions. I guess they can joke. Any other questions on 33 here? All right, 41 or 43. So what do we got? So we're going from -2 to 3. That's not going to narrow down for us at all because these all go from -2 to 3. F prime of 0 does not exist. Okay. F prime of 2 equals 0. So what does that mean? The slope at x equals 2 needs to equal 0. Does that narrow it down at all? It does not. Because you got flat, 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 flat. F double prime of x equals 0. What does that mean? Concave down for the entire graph, right? Because it says for the whole graph. So A has this concave up part to it, right? Kill that one. B has a concave up portion to it. Kill that one. C is still alive, D is still alive, and E is still alive. If I couldn't take the derivative at x equals 0, so getting back to this f prime does not exist, then there can't be a point on my derivative graph when x equals 0. So if I read this graph at x equals 0, there's a point there. Well, that's like, that does exist. At x equals 0 here, is there a point? Nope. You got this one up here, one down here. And at x 0 here, there is a point. So you want this to be D. That's, when you narrow it all down, that's what it fits. Both of them are concave down. The derivative doesn't exist at that spot because you've got like 2 different answers. And I'm probably 2 for 0. Yeah.
Okay, I don't know. So on the original graph, would there be a hole there, or would it be like what would happen on the original?
It would be piecewise.
Okay.
So the slopes come in at different points. So at 0 down here, the slope is -2. So we were coming like down, and then up here now the slope is 2. So we must have flipped back and go positive. So when you get that corner, remember you can't take the derivative at a corner because I wouldn't know which slope to choose.
Doesn't the let f be a function that is continuous contradict d as an option?
No, because it's like a corner. So a corner is still continuous. So I've got a negative slope coming in from this side, and I've got a positive slope going out. But if my original graph, looks something like that, then there's curves because there's obviously wiggles. But at 0, the slope from the left would be going towards a negative number.
Yeah.
And from the right would be a positive.
But aren't we looking at graphs of f? So wouldn't we?
This is still continuous.
Yeah, but the answer you circled isn't.
So those are F.
That doesn't matter because this is f prime.
Which of the following could be a graph of f?
Prime.
I don't see a prime there. That's f question mark.
Oh!
You're right.
No, you are right.
So wouldn't it be e?
Yes. This is actually E. That's a very yes.
Alright. That was more nerve-wracking.
Why is it nerve-wracking?
I'm trying to correct the teacher. That's not the easiest thing in the world to do.
So, I should cross those off. I had my levels mixed up. This is supposed to be the graph of F. And D doesn't, why doesn't D work? So Quinn's right. Why can't D be the graph of F? Because it's not continuous. So I missed that part. And then this, so f prime of 0 doesn't exist here. Why not? Because it's a cusp or a corner. That's actually that's easier than that. You're right. Thank you. Were you going to say the same thing now?
No.
I thought she had caught it too.
Am I the only one saying this?
Dustin, were you going to say that? Is that what you were? Yeah, this is E. That's
As
my
soon as
fault.
Dustin raised his hand, I knew he was having the same thought. Oh, come on, man, let's say it.
My bad. You guys are paying attention, all right? Some of you at least. Okay.
Specifically to that.
Okay. So yeah, please catch me if you. So we're looking for y equals f of x. So these are the original graphs. We know y prime is greater than 0. So what does that mean? Increasing. So it could be A, it could be B. It can't be C anymore. It can't be D anymore. And then y double prime is negative. What does that mean? Concave down. So that puts us to B. Right, Quinn? Get it?
I don't see any tricky printing errors there. So.
Okay, 17. Point of inflection. So, again, they're giving us the algebra instead of the graph. What level does point of inflection come from? Second derivative. So I'm going to have to do some algebra here. So the first derivative would be 20x to the third minus 5x to the fourth. The second derivative would be 60x squared minus 20x to the third. And I want to set that equal to 0. And then solve it. So what can I factor out of both of those? 20x, which would leave me with the 20x squared. So 3 minus x. And so what are my two solutions? X equals 0 and x equals 3. Now be careful here. I remember this question. I don't really need to check the y values. I mean, I can, but I'm pretty sure if I plug in 0, I'm going to get 0, just looking at their choices here. Pretty sure if I plug in 3, I'll get 162, so I'm not going to worry about that. But what you have here are just possible points of inflection. Those are just points that go on your number line that you have to check. So I would actually be stunned if it's D, because I think they're trying to trick you into, oh, it's going to be both of them. But like, seeing if you're going to check them or not. So let's check them. So negative infinity to 0. 0 to 3 and 3 to infinity. And my guess is it's just one of those, because that would make, basically because that would screw most people over. Like, that's what they're trying to do.
They're so nice.
So, I mean, I get it. They gotta run a test that like the smartest math kids in the country, half of them fail. I mean, you gotta make it pretty. That's the game we're playing. So I pick a point from each window and plug back into what level? Into where? Second derivative. You plug back into where you came from. So if I plug in like negative 10, this part will be positive, the 20x squared, and 3 minus negative 10 would also be positive. So we're concave up there. If you plug in like 1, what happens? It'd still be positive, wouldn't it? So that's the trick right there. Is there a point of inflection when x equals 0? There's not. And then if I plug in like 10, I get positive times negative. So the only point of inflection is that 3. But if you didn't check it, you're rushing during the AP test, and you're like, oh, I got my 2 answers. These are both there. That's good. If you didn't take that extra step to check it, you'd have missed it. All right, questions on anything yet? All right, so I don't want to. If you didn't do it because you were lazy, whatever, that's your problem screen. If you didn't do it because you were stuck, I'm hoping this helped you, and you can maybe keep going to page 15 now. Or if you did do it, maybe you can check this over. And I'm just not able to talk for 15 minutes. Maybe you guys pay attention. I can tell I'm pushing it as it is. So finish up to page 15 for tomorrow if you haven't. And then this way we wasted like half a day, I guess. And then we'll start the free response questions tomorrow.
Are the free response questions similar to these? And then you just have to come up with
So the questions are very similar. They do much more often say like justify your answer. So that's when we get into like because f is increasing, because f is positive, because f is positive. But it's the same concept.